So let us go through this code. Basically, you have a main method, you have the implementation of the child, whatever the child does, you have the thread exit, and you have the thread join, and we are going to go through them. In the beginning, you basically you initialize a variable that's called done, and you initialize your lock, your mutex, and you initialize your conditional variable. Okay, so let us look at the code in more details. First, the parent thread creates a child thread. This is basically exactly the code that we have looked at before. Uh, then the parent basically then the parent basically calls the join function right after it creates the thread, right? The join method, to wait until the child completes. We'll look at how join is implemented later, but let us basically look at the child itself. The child thread is now created. It's called, and it prints child, like whatever it was going to do. Now it's printf that is going to print just the word child and a new line, and then it calls thread underscore exit to signal that it is completed. So thread exit looks like this. Okay, you basically have the lock, okay, that you just initialized, the mlock. You pass that, you lock it basically, and you uh, set done to 1. Okay, then you signal the waiting threads, and then you unlock the thread. Okay, so now if there are multiple threads trying to access done, there is only one that can change it at any point in time, right? The thread join works like this. You have basically a mutex lock. You acquire a lock. Then while done is equal to 0. So as long as the thread has not existed, the child thread did not exit, you basically wait on the conditional variable. And when you wait on the conditional variable, you pass both the conditional variable that you're waiting on and the lock that you have just acquired. Okay, so logically what would happen is that the thread join will get called first. So if you look at the main method, once the thread is created, thread join underscore, sorry, it's not dot, it's underscore, thread underscore join gets called. Thread underscore join acquires the lock on m, okay, and checks if done has been changed. And if it's not changed, if it has not been changed, then it basically uh, passes to the conditional wait, to the conditional variable wait function, both the condition that it's waiting on, so it's waiting on C, okay, and it passes also the lock that it acquired, okay, and did not require anymore, because, well, it doesn't need the lock as long as exit is not called, okay. And then when basically now, since this parent thread called join, it's waiting on this conditional variable and on the lock to become available to it, okay. Now the child gets implemented, gets to run, gets scheduled. It does the print statement and then calls thread.exit. Now thread exit acquires the lock, okay, makes sure that no other thread has this lock, okay, sets done to 1, and then signals to the condition C that whatever is waiting on condition C can now wake up, because I am done with whatever I was doing, and then it unlocks M. Okay, so if you're waiting on conditional C, if you're waiting on this condition C, and basically suppose that right before you unlock M, right before you unlock it, you basically get descheduled, you get removed from the processor, and you join gets scheduled. Okay, this can happen. So join will try to acquire M. It will not be able to, so it will just block and it will just relinquish the processor, because now it cannot make any progress. It cannot acquire the lock. So until exit gets scheduled once more, and M gets changed, gets basically released. The lock gets released, unlocked. Then join can actually run whatever it was supposed to run. Okay. So this is basically all that we have discussed. The only thing that we need to say is that sleep is atomic. Okay. So now that move between releasing the lock and putting the cooling thread to sleep is atomic. So wait is an atomic function.